Last July, someone logged into a stranger's private app with a fully verified account, and they did it without guessing a password or crafting any exploit. It was just because of a mistake by an AI. So in today's video, I want to get into why AI written code keeps making the same mistakes and why nobody catches them before shipping and what happens when an app gets bigger. And later in this video, I'm showing you a study that proves wipe-coded apps are genuinely kind of cooked. So first, let's start with wipe coding, what it is. Wipe coding basically means describing what you want in plain English. So the AI writes it, ships it, and there is little to no review often. So it's a general industry term used to describe code that is written by AI. And this one here is a pretty great example of what's happening. Wiz Research uncovered a critical vulnerability in AI vibe coding platform, Base44. So if you don't know what Base44 is, it's basically a platform that allows you to make applications through vibe coding, similar to Lovable and Bolt. But what they did, they were researching on this platform and they found out there are two endpoints that were exposed. So let me show you that. If I go a bit more down here. Yeah, so first they found out some Swagger files, and in the Swagger files they found out the documentation, and in the documentation what stood out to them is this auth section. So basically this section was listing all the endpoints that requires authentication, like login, register, changing your account details, you know, a lot of things that you do once you're logged in. They found out that there are three different types of authentication methods. First is public, that requires login, and the second one is private with beta authentication. This also allows self-sign-up, effectively remaining public. And the third one we have is private with SSO. So the only real private option, restricting access to invited users while enforcing SSO in the authentication flow. So if you are a pen tester or bug bounty hunter, you must have seen those kind of applications while hunting where only the internal employees can log in. You see the login page, there is no option to register, but there is only an option to log in. So that's what private with SSO feature is. Okay, so as you can see that in the app visibility, a user can set how they want to set it, private, public, or public no login. Anyways, so the two endpoints that stood out to them are these. First one is register and second one is verify OTP. After examining the documentation, we discovered an interesting lead which eventually turned into a critical misconfiguration. So this path, API apps app ID auth register, which allows registering a new user by providing email address and password, and there was another endpoint that is verify OTP to verify our user by providing one-time password. So this is normal behavior, but these endpoints were exposed without authentication. These are so important endpoints and they were exposed without authentication. And this allowed anyone to register for private application using only the app ID. So as long as you know the app ID, you can simply register into the application, create a verified account, and you can see the internal details of any private application, which wasn't supposed to be public at all. So this is pretty crazy. Now you must be wondering, okay, this random string, this app ID is random, so maybe the impact is a bit low. Oh, don't think that. The impact is actually pretty high still. It's because to obtain app IDs, it's pretty easy. So this is how the app ID looked like, but they finally discovered that they weren't secret at all. When we navigate to any application developed on top of Base44, the app ID is immediately visible in the URI. So whenever you visit any application, you will see it in the URI. Whoa. Okay, yeah, right over here. And it is exposed just like that to public. So all you have to do is just enumerate, find out all the applications with different app IDs, and then you can replace it, make a call request to the register endpoint, which has no authentication, and boom, you're in. And of course, since there was no authentication in verify OTP as well, you can also verify your account, and now you have a fully verified account in someone's private app. And all of this was possible because of the vibe-coded applications. We usually focus on AI-specific threats like model poisoning, prompt injection, but we forget the basic security controls, proper authentication. And these endpoints were exposed, leading to a critical misconfiguration. And someone actually tested this out with proper research. Theory's Zint team built 28 apps in 3 different ways. First with proper spec, and another one with zero guidance prompt, basically like build me a thing. And third, they gave it an PHP forum and asked it to modernize it and secure. And before I get into what they actually found, the first scan spit up 8,827 findings. Zin platform automatically collapsed the duplicates, which came down to 513 distinct findings. From there, Zint team didn't just take scanner word for it, they also built proper proof of concept, and 434 bugs held up to it. And those are real exploitable bugs. So let's move on to finding number 1. It's pretty surprising because it's actually missing rate limiting. Resource exhaustion DOS was the largest class of flaws found regardless of severity. So imagine a OTP verification page. Let's say you logged into the application, now it's asking you to verify your account. So you have to provide a 4-digit password, but obviously there should be limits to it. Like if you try to guess or write 5 OTP and all of them are wrong, then you will get a rate limit. So to prevent hackers from exploiting such features by guessing all the possibilities of 4-digit passwords, rate limiting is used. And apparently this one was not implemented by the AI coded apps. It's really surprising for me, honestly, because I thought that's really basic thing and AI would just, implement such things. So yeah. Though the code compiles, efficiency and performance are cross-cutting operational concerns overlooked by models when a developer only asks for features. Interesting. Don't let this be called a million times is rarely in the prompt or example code or model learned from, so it emits the working endpoint and omits the guardrail. Okay, and the second finding we have here is secrets exposure, and it is the top source of critical severity bugs. Secret exposures like default secret key or a JWT secret that lets attackers forge sessions or tokens. And this is pretty critical because if you can forge tokens for any user, you basically have access to their whole account. You can even delete their account, because JWT are the soul for authentication and authorization in that application. So let's look at why this is happening. These are the copy-paste quick start defaults that dominate training data and do not change whether the app runs. So what this means is that, as we know, models are trained from training data, and these training data come from online sources, licensed sources, and many other sources. But most of this data has this quick guides, okay, get this application running in 5 minutes, quick start templates, guys, and they do not implement the complex structure. They tell you to implement the easiest structure, the easiest JWT default structure, and that's why AI learns. It follows, okay, this is how it should be done because that's how majority of the training data looks like online, and that's why these models implement it and these type of bugs come to surface. So look for hard-coded secrets such as API keys or PII embedded in code produced by AI. And honestly, this is exactly what Zin catches. It scans your code at scale and also finds logical bugs that standard scanners miss. And they also launched Zin Pulse too. It's a one-off scan size for a single app instead of their whole enterprise platform. So if you want to check your own AI project before someone else does, it's worth a look. Go check out the Zin paper that I mentioned and Zin Pulse from the link in the description. Okay, moving on to finding number 3 we have is authorization related bugs, my favorite category of bugs when I'm hunting. So we have fine-grained authorization holds up on small apps but breaks as the app grows. Means that the authorization works fine, obviously, when the app is small, less features, less to be taken care of, but when the app grows, tons of features, tons of roles, the AI gets kind of confused. As we know, like when we try to give a lot of tasks to AI, it gets confused. And that's why I always say in my previous videos as well, like whenever you're working with AI, you want it to find some particular bug, just focus on one bug at a time. Don't ask it to find all the bugs, different type of server side, client side, everything. No, don't do that because it will get confused and you will get duplicates. It will even miss some of the bugs, and that's exactly what's happening here. So we have an example. The simple cases like stopping someone from editing another user's post were handled well in small builds but fell apart at scale. Either a type of flaw where a user get access to data beyond their permissions was only 11% of the findings in these small applications, but largest share of flaws at 28% in the large G7 app. So if you are someone who's building huge applications with tons of features using AI, you gotta check it out for IDOR bugs or authorization related bugs. And again, we have why, but I already explained that. It's because as the context grows, the AI gets kind of confused. Isn't that pretty surprising though? Going through this, the assumption was that AI written apps would be full of classics like SQL injection, cross-site scripting, or SSRF, stuff like that, but that barely showed up. Turns out that the models have gotten pretty good at managing those type of bugs like parameterized inputs, standardized inputs, and save defaults without asking for it. And it seems like it's the bugs that nobody usually talks about much are the ones that are showing up in AI written apps. Because if you look at it, that security courses or people in general talk a lot about SQL injection, cross-site scripting. There's a lot of data on it online, and that's the type of data that these models have been trained into, and that's why they're good at it. But the things that we don't talk much about are the ones showing up in AI. So as someone who is writing vibe-coded apps, make sure that you're also checking for these type of bugs when you are prompting it. Thank you so much for watching this, and I'll see you in the next one. Bye bye.